Alright, let's do this one. We got a box, 50 newtons force of gravity, sits on a frictionless surface, force normal. We don't know what force normal is because I've got a rope that's 4 newtons. Now, got to be careful here because the only thing is this is the x direction. So this is 4 newtons. Whoops, we got to put a 25 degrees in here. 4 newtons times the cosine of 25 degrees. There's also a force here of 4 newtons times the sine of 25 degrees. So my force normal is not equal to my weight because I've got this bad boy to take care of. Now, what we can do though is find there's no friction, so the force in the x direction, I should be doing this in red. The force in the x direction equals mass times the acceleration in the x direction. The only force in the x direction is right here. 4 newtons. Okay, I'm better now. 4 newtons times the cosine of 25 degrees equals mass, which is 5 kilograms. And I gotta solve for A. 4 newtons times the cosine of 25, I think it's 3.6 newtons, equals 5 kilograms times acceleration in the x direction. A would equal 3.6 newtons divided by 5 kilograms. And I think that comes out to be about 0.73 meters per second squared. Now, they asked me, they, meaning me, I got acceleration. The weight, I have that. I need this normal force. So, this, it's not accelerating. There's no acceleration in the y direction. No acceleration in y direction, which means sum of the forces in the y direction equals 0. I've got force normal, I don't know what it is. I've got 4 newtons times the sine of 25, that's right here. And then I have to subtract off 50 newtons. Those are all my y forces, vertical, and that all equals 0. Give me a little room here. 4 newtons times the sine of 25. Is that what, 1.7 newtons minus 50 newtons equals 0. Force normal equals 50 newtons minus 1.7 newtons. Force normal equals 47.3. 47? Yeah. Yeah, no, 48. What kind of an idiot cannot subtract 50 and 1.7? I'll tell you who, me. Just didn't look right. That's 48.3 newtons. Leave me alone, I'm tired. Bye-bye.